The session is on technology and innovation. The topic chosen for the year, pasteurization. Also, we have a presentation on the economics of electricity generation from cashew shell. To moderate the session, I invite Mr. Shakti Pal, TechnoServe, to please come on stage. Mr. Shakti Pal is the global lead of cashews at TechnoServe. A huge round of applause for Mr. Shakti Pal. Joining him in this session will be Mr. Stefano Massari, MD Ultramare, SARL Mr. K.S. Jayaram, Director TMPL, Mr. David Barbera, Business Development Director, Napocell AG, and Mr. James Oborowski, Program Director, TechnoServe Benin. If I may please request all the gentlemen to come on stage and start this next session.
Well, now, last 2 days, we hear a lot about the trends in consumption of nuts, and specifically this precious nut which we call cashew nuts. But at the same time, we also hear the consumer is really, really worried about his health. He's always talk about good nuts and healthy nuts, but at the same time they talk about is it safe or not. So this session this is on innovation and technologies, and we will take two very, very important tasks here. One is to ensure the biggest need of quality in terms of the pest and microbiological contamination on the nuts. And then the second is how to gear up to get additional revenues and how to use the cashew shell cake into putting up something which is precious, which is energy, power generation from that. So we have here three distinguished speakers who are going to talk about their experience, their innovative products, to talk about pasteurization, which is one of the way to secure this food safety requirements. And then we have one speaker who is going to talk about how we can use the cashew shell cake in having power generation. Like it is, yesterday in one of the presentations of Jan Vincent, he talked about price is a problem, but not the biggest problem. Then what is the biggest problem? The biggest problem is the food safety, where consumers choose to eat more nuts. They are also very much aware of the threat that it can have some microbiological contamination, and they don't want to see anything. Before they say it's good food, they want to make sure it is safe. So in the same way, in recent past, if we see, it's so frequent these days to hear about some outbreaks. It was very rare to see this in, let's say, 1990s and 2000 on cashew side. How it started, actually, it started in around 2000, 2001, when the very first outbreak was noticed in Canada on almonds. And that's where people start thinking about that this is going to be a problem. And then various frequent outbreaks came in. Industry was not very able to address them properly. And at last, in 2007, USDA, like FDA, come up with some regulations that industry has to pass through a process which is pasteurization of nuts. It's an obligatory thing. In the beginning, there was a lot of concerns about it. The industry opposed this, but at last, because there was a law they have to start with, and today they are so proud that there is no more recalls, no more contamination on almonds parts, because California almonds are purely like every single kernel have to pasteurized. So with this great experience, the consumers really start understanding that's what happened. Other tree nuts, they took this example. They also start having same sort of issues. Like in last 6 years, there are more than 11 cases of recalls which came in cashews, and then other nuts. Recently, if you see, cashew is just very new. People always feel that cashew already have passed through a process which have one way or another way of pasteurization. But is it really enough? Can it guarantee you the success? And we find in last 5 outbreaks that yes, it is not enough actually. Pistachios, hazelnuts, we talk about like walnuts. Those industries took this seriously and they are addressing this problem very well. Cashew is a new startup. And I'm very happy that in last 1 year, I saw a lot of factories, they start addressing it properly. They start having pasteurization process within their factory rather than just taking it as an outsourcing service. So and I see sometimes we take this as a law, you know, like there was a regulation coming in, and that's why we just say, well, now we have to do it. But that's not, I think, cashew is not yet there. So we have to take a proactive approach, learning from almonds, learning from some other nuts who are already addressing it properly. And yesterday we see this buyers also say, because this is, price is not the biggest problem. We have here 3 pioneers in pasteurization. There are more than 9 companies who have technologies to address this. Here, I would like to invite Mr. David Barbera, who is the business development manager for Napsol. And Napsol is one of the pioneers, actually, in bringing pasteurization. They have, I think, more than 35 or 40 setups and all over the world, different validation processes, customer validations in place, and they are, I think, very well matured about pasteurization. So, David, the deck is yours.
Good morning. Sorry for my voice. A sore throat is killing me. Okay. Thank you for watching this video with us. So, Napazol is a Swiss technology. We have about more than 30 plants around the world in the low moisture food. So we're the leader in the nuts industry, in the spice industry. We have also units in the dried fruits all around the world, in China, in Australia, in South Africa, in California, in Europe. So our technology comes from the sterilization technology of pasteurization from the medical industry. We adapted it to the food. So by doing a partial vacuum, we go very low in temperature, which allow us to deactivate the enzyme responsible of oxidation without damaging the shelf life. We actually proved that we can increase shelf life on nuts. So we have a fully validated process, both by the Almond Board and the different third-party laboratories around the world. We guarantee a 5-log reduction on every tree nut, nuts, and spices. And of course, our technology can bring also the kill of yeast and larvae and eggs. What differentiates us from the other technologies in the market is that we use saturated steam. I don't know if you're familiar with that concept, but most of the systems on the market using steam use ambient pressure, which means wet steam or with water droplets. Using saturated steam allows us to get the maximum efficiency of heat exchange between the condensation of the water and the steam on the product surface. So as you can see on this graph, if you go in a partial vacuum, you actually can deactivate enzymes around 80 degrees, 85 degrees in tree nuts. And of course, not getting over 100 degrees, that would actually decrease the shelf life of your product. So in this case, you need to be in a batch system. You can't go continuously in a process and achieving saturated steam conditions. This is typically a recipe for tree nuts. In this case, it's for almonds. And as you can see, we treat almonds at around 90 degrees Celsius, and we get up to 7-log reduction on almonds. All kind of almonds, Spanish almonds, Australian almonds, Californian almonds. So you can see the first part of the batch is you have a preheating phase. This is very, very important for our process. We actually use dry, hot air to bring the product in temperature high enough to use the minimum amount of steam on the product. This part, you can bring the product from 20 degrees to 70 degrees with dry air without modifying the moisture, without having any color change on the product, and of course, skin lifting in some different kind of tree nuts. And then the pasteurization happens where we pull a very strong vacuum. The vacuum is very important in our process because we don't move the product. The product sits in a bin, so you don't have any damage, you don't have any split of your cashews, you don't have any color change, and no moisture pickup. The moisture at the beginning and the end of the process is the same. So we put a very strong vacuum down to 50 millibar. This allows us to get rid of the air, which is resistant to heat transfer. Of course, you can't go in theory, yes, but in practice, you can't really go at 100% vacuum, even with the most powerful vacuum pump. So what we do an injection of steam a first time to actually help reduce the amount of air which is around the nut. So then we do a second vacuum. Then we get rid of about 99% of the air. And then you see the main injection of steam here, where we go up with 12 bars of pressure of steam, saturated steam. It's a reverse osmosis water which has been evaporated, so it's purely organic steam. So you get organic certification for this process. And the whole part here just lasts about 6 minutes. So it's only a 6 minutes pasteurization. So the water which condensates on your nuts just stay on the surface. It kills the bacteria, the larvae, the eggs, but it doesn't penetrate your product. So if you enter with 4, 5, 6% of moisture, you come out with the same moisture. Then we put a last vacuum, a very strong vacuum to get rid of the water on the surface of your nut. By putting a strong vacuum, you actually evaporate the water very quickly. And the last phase, the cooling phase, is just to get rid of the steam and the potential heat around the product. And you get down to the ambient pressure and temperature, which gives you 20 degrees. just to show you that it's a validated process, so you get a batch report at every lot that you process. So it's FDA approved, it's FISMA regulated, so you have actually no issue to show and prove the US government that the product has been pasteurized. I don't want to be too long, so I would like to end up my conversation here. Thank you for your attention.
Thank you very much, David. We noticed here when we say saturated steam, I think many people feel that steam is a great thing on pasteurization, but not on nuts. But it's a very, very good way of doing the pasteurization, which is very uniform, using a sort of vacuum process, which doesn't affect anything. That's a great thing. Thank you, David. Before we go into questions, I think I would like to take first three speakers, because they have the same sort of issues, and then we will ask, we'll take the questions later. I would like to invite now Mr. Stefano Massari. Everyone knows him so well in the industry. He's the managing director for Ultramare, and Ultramare actually have an innovative product. They have very get together with cashew industry actually from the very beginning. They come up with a solution on a continuous pasteurizer and infestation control system, and which is well integrated with all food safety regulations. Please welcome Mr. Massari on the stage.
Thank you, Shakti. I think it's better to send the video and then I'll speak on. What you have seen here is an integrated approach. I would like to speak a little bit more in what is a comprehensive approach to food safety. Okay, it's not only a matter of pasteurizing, fumigating, or cleaning and packing. We need to see this kind of activity as a joint set of activities that brings to the quality of the product. So what we have presented here is something which is fully integrated. Okay, what you see now in a common cashew factory is there is the fumigation section, then there is the cleaning section and the packing. All of them also engineered in a layout in a separate activities. Our approach is a bit different and goes towards the full integration of all these activities to comply to the food safety rule. So the idea here is to to have a line that pasteurizes, eliminates the insect, remove the insects and the other foreign matter for the product, and then go to packing directly without any, minimizing the risk of cross-contamination. There is no use of pasteurizing or fumigating if you have the product laying in the factory for half a day before being packed. So here the matter is really is a sort of change of paradigm, is a mindset, is a situation in which we have to see the last part of the process as a full continuous in so to have the maximum benefit from this activity. So we have already experimented this in our service company that we have set up in Rotterdam, where we treat kernel which is out of specification. There is a full complete line for the cleaning and the removal of foreign matters and the packaging and the rebagging of the cashew, and eventually will be integrated with the pasteurizer. But this is the way we think this kind of matter in cashew has to be approached. So to give your customers and buyers the guarantee that things are done in the proper way, there is a need of a full integration of these activities in the food safety area, which include pasteurization, of course, what is called fumigation without chemical. I use fumigation in an improper way, but just to make myself clear, so the elimination of the insect and their potential hazard, and the removal of foreign object, and the packaging of the product, the final vacuum packaging of the product, being that in big bags, as you have seen in the video, or in the traditional 50-pound pouches. So the message I would like to send here is that see the food safety compliance as a set of homogeneous and complementary operation to be done at the end of the process. I would be pleased to receive your question later on. Thank you, I'm finished. Thank you.
Thank you, Mr. Massari. The message is clear: integrated system to allow a comprehensive food safety compliance. Cashew is a very batch-to-batch sort of process, and we frequently do this mistake that we do something, we treat something, and then we leave the product for maybe half a day, and then we find that the system is not working. So I think that's a great approach to address this properly. A very well system which is really fully integrated till final packing. I would like to invite our third speaker, Mr. K.S. Jayaram, who is the managing partner for TMPL Machines. They are based in Bangalore. It's an Indian company. They actually recently developed a pasteurization machine with the converted infrared and ultraviolet radiation at different temperatures. We saw their machines in many factories. It's coming up. It's a new technology, and I think Mr. Jayaram is going to talk about what they are bringing to the industry. Mr. Jayaram.
So the various methods of preserving the nuts. So we have got hot pasteurization as well as cold pasteurization integrated in line. Thereafter, once the nuts are sterile, you can do packing. The first is the hot pasteurization. I'll just explain to you regarding the technology. So infrared is in a certain wavelength. It is already part of the sun spectrum, which we receive naturally. And it is the most recent tool for direct heating. It can kill bacteria like salmonella, in almonds and cashews, as well as in dry foods. It can also kill insects, the eggs and larvae which are inside. So basically infrared penetrates to a few millimeter and thereafter it conducts to the core of the nuts very quickly. So the hot pasteurization is done in 2 minutes or even lesser. Why do they kill? Infrared has got a natural affinity for water. See, when we go out, if the sun is hot, we feel very hot. 30 degrees, 35 degrees, it goes to 40 degrees, we still feel hotter. It is the power of infrared, and we humans have a lot of water in us. Same is the case with other living organisms, like bacteria and insects. So if the cashew kernel temperature may be around 70 degrees or 80 degrees, the temperature of the living organisms will be much higher. So they get killed quickly, very quickly. So it's a type of pure radiation, a light energy, which is absorbed by the objects without any physical contact. You have infrared on the top. We are using a special belt which, when absorbs the infrared energy, gets heated up, and in turn, it gives back infrared. So if it is 100% infrared from the top, maybe you have about 95 to 98% infrared from the bottom too. So when the product is moving through a multi-layer, multi-deck conveyor, you can be rest assured that as the kernels move from one belt to the other belt, they get heated up very uniformly. And another thing regarding this is due to quick heating, it is validated by research by CFTRI as well as Indian Institute of Technology, Kharagpur, in collaboration with Jain Institute of Advanced Studies, that quick heating does not, there will be no loss of nutrients, uniform heating, no change in color, and these are some of the advantages over convection heating. So basically, we are using 2 to 3 different wavelengths. We are using shortwave IR for edge and internal heating. We are also using medium wave IR, which operates around 5 microns wavelength. So it has got a natural affinity for water. Rather, water has got a natural affinity for this wavelength. In some cases, we also use long wave, wherein the change of color is required. So basically what we have done in the infrared module is we have combined different wavelengths together. So if you see, the sun's energy which beats down on the earth is around 1.36 kilowatt per square meter, whereas we are using in our equipment almost, there's 9 kilowatt per meter square. There's almost 7 times that of sun's radiation. So the next module, after it passes through a flight conveyor, is the ultraviolet and cooling, what we call as cold pasteurization. So this again is part of the sun spectrum. Fortunately for us, because of the ozone layer, of course it's depleting, we are not getting it. Otherwise, we human beings also would not have survived. So how does ultraviolet light kill microorganisms? See, this ultraviolet light sterilization is very environmental friendly. It kills bacteria, mold, fungi, and viruses without the use of any harmful chemicals, and does not produce any residues, corrosive materials, or disinfection byproducts. So how is this achieved? Sterilization is achieved, it's not achieved using chemicals or steam, but through a special wavelength which you get from UVC lights. You use these UVC lights even for, pasteurizing water, which is also used in the beer industry. So it's also known that after these products are made sterile with ultraviolet, it also increases the shelf life, the storage life of the product. So previously, herbs and seeds were either not sterilized at all or were sterilized with complicated processes, exterior technologies in some cases like Boma, chemicals, steam, etc. And the problem was, valuable contents, nutrients, essential oils were lost during this process. Also, UV light sterilization effectively purifies the air through which the product is passing through without the use of any chemicals that may be cancer-causing, carcinogenic. So basically, how we are different from others? We are using, a modular technology, which is a combination of two different technologies, which has been proven since the 60s. So we have just adapted it. We were using this in the electronic industry. We were also using it in the automotive industry. So in 2013, with the collaboration between the supplier and the industry, we came out with this technology and equipments. Since then, we have sold more than 40 equipments, both in India and Africa. So you have a layout. Basically, you have a feeder hopper, a flight conveyor, one more feeder hopper to pass the product as a single layer. And as the product passes from one deck to the other deck, one layer to the other layer, the product changes, moves around so that all parts are uniformly treated with infrared. Again, it moves through a flight conveyor, a hopper again to feed, a vibratory feeder hopper again to feed it as a single layer. So there you have a recirculation fans and ultraviolet in 3 zones. So when it passes from one layer to the other layer, they are once again pasteurized or sterilized. After that, you can have before or after, as per the customer requirements, an inspection conveyor, a metal detector. And it can go through a silo or a hopper directly even to the packing lines. So this modular disinfestation and pasteurization line, it integrates a validated kill step into your production environment. Modules can be added or removed during upgrades in future. See, basically, we have infrared, ultraviolet. There are people also using radio frequency, microwaves, and off late, the latest technology is ohmic technology. So as the technology, is incorporated into the industry, you can add or delete modules in a conveyorized process, which may be very difficult in a batch process. So you don't waste a lot of money, the capital equipment is low, the running costs are low. We have also, this is basically one of the demands of my suppliers. So with an independent third-party NABL accredited laboratory, we have assisted our customer for greater than 4 log reduction at 60 degrees, more than 5 log at 70 degrees, and more than 6 logs at 80 degrees. We have the data. You ask for it, you'll get it. I also want to add that in collaboration with this third-party laboratories, it may be your choice. We work with them and get you the report. And thereafter, periodically, you can get this certified through these labs, which are available, I think, abundantly in India and also abroad. Okay, finally, it's only a documented process can withstand the legal challenge that the nuts processing industry and retail business is facing with today. Okay, we are using a trusted nano concept and inline technologies, which is quite new, I believe, to the cashew industry. Our nano stands for no automation, no operation. Thank you.
Thank you, Mr. Jaram. One thing we notice here, we talk about greater than 4 log reduction. Log reduction, actually, when we talk about log 4, log 5, log 6, is a mathematical term in analyzing the impact of reduction of the microbiological contamination. And FDA minimum requirement is 5 log reduction. Okay, let me take one question actually. When you say this log reduction, I think all 3 technologies you talk about, would your system allow to have minimum 5 log? And if it is just 5 log, do you also expect to go for 6 or 7 log reduction? What do you think about the log reduction? And anyone of you, yes, I think.
1 log reduction is actually 1,000 units, like 1,000 colonies. So when you talk about a 5 log reduction, you multiply by 10, 10, 10, and then you get like the reduction that you need. So if you start with a 10 to the power of 5 or 10 to the power of 6, so you get a 5 log reduction, you get to 10 to the power of 1. So the Almond Board recommends a 5 log reduction. Then it's up to the customer to have a fine tuning between the reduction in the TPC and the quality of product he wants to achieve. Obviously, if you go to a 6, a 7, or 8 log, then you get closer to a sterilization, which means getting rid of all the bacteria and microorganisms in your load. You don't really want to do that in the nuts industry because of the oil content, because of the volatile elements, the flavors, even sometimes the fragrances. So you want to have low treatment as possible, get rid of the pathogens, that's what you want to get rid of, Salmonella, E. coli. But hopefully, and the great thing about pathogens are the first to die. So if you get a 5 log reduction, you get rid of the pathogens, you get a pasteurization and not a sterilization, and that's enough. So I would recommend a 5 log reduction, but not less, because you never know the load of bacteria starting or entering your factory.
Hello. So basically, a log reduction is reducing almost 1 million bacteria. So we need more than 4 log or 5 log or 6 log. Basically, in our system, we can add modules. So today it could be 5 log, tomorrow it could be 6 log, tomorrow it could be 7 log. So we can add UV modules, we can add IR modules as per your requirement, and the treatment time can be changed. So the industry can adapt as per the requirements of the nuts industry. Thank you.
Well, in our case, the system has been designed to achieve the log 5 reduction. Because as Shakti said, that is the requirement of the FDA, and that is the major requirement by the industry. So we have targeted that type of reduction. Going beyond, of course, is always possible, but as it has been explained, may not be necessary all the time. Then you run into other type of problem on the sensory and on the moisture and all this kind of problematic. So we targeted the log 5 reduction, and we got a validation for that from a Bureau Veritas microbiological lab.
Yeah, thank you, Masari. Like 5 log reduction proved that there is no more contamination. Like that, a lot of studies have been done which talks about 5 log reduction means no salmonella, no E. coli or listeria, that sort of pathogens. Any question? Yes.
Hi. I have one question for the systems, because I think there's three approaches. And the first one was very clear that the temperature is quite low, and then there's no colorization, no difference in the color in the process in the end. But the ultramari, and I'm sorry, I didn't catch your name. There's a very different approach. So how is the color differentiation or the control to the temperature for the color of the kernel? Thank you.
Yes, even in our case, we maintain the temperature at a level that doesn't have an impact on the color. We play more on the residence time, rather than on the temperature. We don't go beyond 80 degrees, which is a normal temperature, which is used also in the drying of the kernels, and guarantees that there is no. And we play more on the residence time rather than on the temperature.
We too maintain temperatures as per requirements at 60, 70 or 80, whatever is the requirement. And already for almonds, I believe infrared is already a validated, the validation has been done by Dr. Pan Zhongli, who is connected with US FDA. And he has used infrared alone, and off late he has been working on walnuts too. And this has been a proven process. There is no color change. And in India, research has been done wherein it has shown that quick heating, the nutrient value does not change. Even FDA was also done. Dr. Pan Zhongli was been the father of IR in the USA. And also there's a lot of research being done in Japan. They even have an association called JIRA, Japanese Infrared Association. They're using it more for treating rice and other products. And ultraviolet of late is just not for water, it's even used for fruit juices and other type of natural foods too. And the process is slightly different, but basically it's a matter of adaptation of these technologies which has been there quite naturally for a very long time. And there are a number of equipment manufacturers, even in UK, for infrared. You know, the race horses, they are more susceptible to, nutrient changes. So the process is called micronization with infrared. So there is a company manufacturing equipment for human as well as animal food. In Germany, a lot of companies are manufacturing conversed ultraviolet. So basically what we have done differently is we have made a combination of both the technologies in modular form. So this is a system that is not new. It's been in existence for quite some time.
Thank you, Mr. Jaram. David, do you want to add something?
Thank you for your question. Yes, I wanted to be precise on the way we achieve the log reduction. Obviously, you said about temperature, and there is no miracle. There is two ways of getting rid of bacteria, or it's through heat transfer or by oxidation. Any other technology or science doesn't work. So in our case, we use heat transfer, and the best heat transfer is saturated steam. So because you can treat a variable quantity of products, like you can go like macadamias where you have 4% moisture, you can't really go with any kind of heat transfer. You need to bring the energy from something else. You can't use the energy from the max because there is no water in it. If you use spices, if you use seeds, chia seeds, flax seeds, if you use cardamom, you need to bring heat. And what we found is saturated steam is the best way of doing it. And of course, our competitors can defend themselves, but in our case, this is the way we do it.
Thank you. I think we can take one more question and then we go. If not, I have one more question actually. You see, most of the processing before we talk about pasteurization was using chemicals to address the infestation part. They used aluminum phosphate or phosphine generator. When you talk about your technologies, do we need them still? Like if I adopt your technology to pasteurize and have this 5-flow kill, what do you think that we should continue with the system which we already have, or it completely eliminate the chemical use?
So in our case, I couldn't go more in the slides because we didn't have much time, but we don't use black steam to be in touch with the nuts. We use a reverse osmosis water, which is then evaporated. So make it for non-technical people, we actually have a organic steam in touch with your product. So you can certify the system organically. So we don't use chemicals. just to make it short, black steam is actually non-stainless steel boilers, which brings chemicals to the water, which is then evaporated as steam and then brings chemicals to your nuts. If you get a RO unit, a reverse osmosis system, that will filter your water by membranes, it gives you a free chemical water. Then we then use the black steam as an indirect source of heat to evaporate this water and to get in touch with the nuts. So it's a free chemical technology. And the advantage of not using fumigation or any chemical technology is that we don't reduce the shelf life. We don't oxidate the product. Chemicals are an oxidant. By using a clean steam, we increase the shelf life, and explain it why before is because we deactivate the enzyme that's responsible of oxidation, and without damaging the cells, without getting damaging the cells, which bring out the volatile oils, which then is oxidating your product. In case of hazelnut, we proved that we can increase the shelf life by 15%. I can't make names now, but we are working with the biggest hazelnut manufacturer in the world, and we've been doing for 2 years extensive shelf life study, and we will get the results soon, and we increased the shelf life by 15%.
The question is like, do we really need to continue with our process if we adopt pasteurization? Yes or no? Means no. Okay.
So even in our case, it's the same. Being the pasteurization heat transfer, the same heat used for pasteurizing is effective on the insect and their derivation. Let's say the larvae and the eggs. The matter, what we propose is something that, having eliminated the insect in an organic way, so without the use of any fumigant, then we have to remove them, because we have the dead insect inside the stream of the product. Then we have to remove them, so to have in the package a product which is free even of dead infestation. Okay, so that's why the integration, pasteurization, insect treatment, cleaning, and then packaging.
Thank you.
Without chemicals.
The answer is no chemicals required if we use a combi technology like what we have proposed. So both aerobic as well as anaerobic bacteria are killed in this process, basically because both while heating as well as while treating with ultraviolet, cold pasteurization,
Thank you.
the DNA structure itself is changed.
Yeah, thanks a lot. Okay, I think if we have more questions, you can just send us those questions to the participants, to me or to Cashew Info. We will make sure that we will come up with answers. Let me go for the second phase of this panel. Everywhere we talk about cashew processing and byproduct, which is cashew shell, and we use cashew shell, extract CNS cell, and then still we have big log, which is cashew shell cake remains. Some countries have quite good uses of it. Other countries are thinking what they can do with this, like Benin, which the Benin have a lot of, it's an energy deficient country actually, 175 megawatt consumption. Most of it is imported from nearby countries who are already having some problem with energy. And that time, like thinking about using cashew shell cake in power generation is a great idea. It's not just using it efficiently. We are addressing environment and creating quite a lot of wealth out of this product, which is not used right now. I would like to invite James Obrowski, my colleague who is the country director for TechnoServe in Benin, who's taking care of Benin Cashew project. And they just finalized some work, feasibility study on power generation. And he's going to share that what are the findings of it. So you will see this is happening in Africa. James, the deck is yours.
Thank you very much, Shakti. Good morning, everybody. I'm here to talk to you guys a little bit about a feasibility study that we just completed. It's just an example. There are many variables, but we're hoping that this will get people thinking a bit about power generation from cashew, particularly in Africa. We're here courtesy of the Benin Cashew Project, which is funded by USDA, who's been a great supporter of developing the cashew industry across Africa. So, cashew shell. a waste or resource. As hopefully everybody in this room knows, up to 70% of RCN by weight is actually from the cashew shell after processing. And some processors have invested in CNSL extraction. That leaves you still, though, with about 0.5 kilogram of de-oiled shell as a byproduct. About 20% of that shell can be used for steam needs in processing for the actual processing facility, and the remainder is a waste disposal challenge. If you're sitting in Asia, in India, and Vietnam, this is probably less of a problem because you have good markets for off-taking that product. But that's not necessarily the case in West Africa, where we have a less developed industrial environment. In Benin, we anticipate at least 24,500 metric tons per year of shell waste by 2022. And at present, that shell waste is being burned in the open. It's actually a nuisance and a problem for neighbors and the community. There we go. I'm not going to go into detail in this presentation on the technical aspects, but it is technically feasible with various models to generate electricity, but scale is key to do so efficiently and to have a steady production of power from the turbine. There are different models. You can combine it with steam generation or as a standalone production of electrical power. Why is this interesting? For African processors, they're facing a very different environment. We talked a bit yesterday about, there was a conversation about the cost advantage of processors, particularly in Vietnam. That comes from a number of factors. Infrastructure is, of course, a big one, and that includes electrical supply. You can see here in the specific numbers vary extensively within countries, but the overall trend is clear that there is a big gap in terms of the cost of electricity from grid or from diesel generation. Between African processors and those in Asia and Vietnam. The other issue that's maybe hidden here is reliability. So although Nigeria has lower electrical costs from the grid, the reliability of that grid is such that they might not be able to use it. And it's not just the on or off, it's also the quality. I've seen plenty of processors, not just in cashew, but other industries, go through some very expensive equipment and control units because the frequency of the electricity or the voltage was inconsistent, and that damaged their very expensive investments in mechanization. So what's the competitive impact here? As a processor scales up, obviously their consumption of energy is going to increase, and the trend in the industry as we're seeing today is towards greater mechanization, which exacerbates that problem. The more steps you have mechanized, the greater your power consumption. As a result, a fully scaled processor in Africa could be facing as much as $400,000 a year in electrical costs. There's a substantial weight on their operation and profitability. So this is just a brief example of two different models using a 1 megawatt and a 2 megawatt power generation. This can supply the cashew facility itself, or if there are multiple agricultural processing lines on site. The model that we ran here in this study was based on using all power on site. I'll get into a little bit more of why that's interesting in a moment. But as you can see, the rough numbers are extremely attractive. Just earlier, I showed you that slide with electrical costs of over 20 up to 25 cents per kilowatt before fixed fees and other levies. And here we're looking at 6 cents, which is competitive with the electricity costs in Vietnam and India. The fixed cost is relatively low and manageable, which ensures a recovery of your investment within about 2.5 to 3 years. Even with other variables, we expect a plant like this to be operational for at least 10 years. So this is showing a very positive internal rate as an investment of 18 to 25%. So what are the key considerations for whether this is viable or should be investigated and a feasibility study done for a processor? The cost of electricity and diesel, of course. That's your opportunity, your alternative source of energy, and if the costs are very cheap and that power is reliable, then this might not make sense for you. If they are high or unreliable, then this is worth considering. The reliability and the quality of grid electricity, as I just noted. Scale. You need substantial amounts of your own production of shell. So for a 1 megawatt plant, we're looking around 7,500 tons of de-oiled shell cake. The availability of alternative fuels to ensure your supply and keep that turbine running. If there are other fuels such as waste from the cotton processing industry, from maize, then that can help ensure a steady supply to your turbines and possibly offer you greater scale to go up to 2 megawatts from a combination of fuels along with cashew shell. The ability to find synergies with other processors. This is to ensure that supply again. If you're able to supply all of the de-oiled shell, that's fantastic. What we may see in some places in Africa is a cluster of processors where an individual one may not have the full scale to pull it off, but by pooling together, a lead processor can have the full-scale CNSL extraction plant, as well as the electrical generation, and pay the other processors for their unwanted or unusable cashew shell. The opportunity cost of selling the de-oiled shell to other industries, of course, is an option. If you have other industrial users who are willing to pay a high price, then that will reduce the profitability of making this investment. And finally, the market for the energy produced. There's a big difference between feed-in revenues, which are in most countries in Africa don't exist yet, although there's a few initiatives, including by Millennium Challenge, to introduce these policies in Africa for decentralized power production. But in most cases, they may not be available. And so your own needs or a microgrid, especially in rural areas, might be much more attractive. If you're able to use all of the power on site, this is the most optimal situation. Thank you very much, and I look forward to answering any questions that you have.
Thank you very much, James. I would like to recognize the efforts of Mr. Rajkumar, actually, who is a pioneer in it, who have 6 megawatt electricity plant in India, and who supported also with his good ideas that how we can actually come up with such a study in Africa. So thanks to Mr. Rajkumar if you are here, if not, but like we recognize your efforts. We have more or less 5 minutes now. Just we can take one or three questions.
Thank you very much. That's an excellent question. There's two elements to this. One is to understand what the baseline situation is. As of right now, due to the issue of disposing cashew shell, most processors in Africa are not able to remove the CNSL. And they're simply burning the full cashew shell that remains after their own needs out in the open. So we're starting from this baseline situation where we already have a big environmental and pollution problem. The business case that we're looking at includes environmental controls. So there are filters and other pieces of equipment that have been added to the power production unit in order to control those emissions. But this is a primary concern in the business model that we're looking at.
Yeah, I think there are a lot of technology available which allows you to have 99.95% combustion, and that allows you to actually control. There are a lot of various ways these days. The technologies are well advanced these days. So that is taken care of. Like it is not a concern these days because it's de-oiled shell cake, but at the same time you use some other means of having addressed this properly. Yes.
Yeah, Shakti. Yeah, currently we are producing around 20-25 metric tons of shell cake. So we are finding a lot of difficulties in disposing of the shell cake. So just I request James to look into any alternate buyer for that. So currently, monthly we are producing 500 tons. We are holding almost 2,000 metric tons of shell cake, and we are losing value. So you need to find out solution. Maybe Burkina Faso, maybe other area, if anybody's buyer is there, it would be great help for us. James.
Would you like to say something?
I'm not sure if that was a question or a request to discuss directly after the conversation, but we'd love to sit down and look at whether it makes sense for you from an economic standpoint, or if there's a way to team up with other processors to make it happen.
But if you see also the feasibility study for 1 megawatt, that requires around 7,600 metric tons of de-oiled cake, which is exactly what you're producing right now. And that has $1.3 million revenue. So I think it's a matter of just a little bit more investments, and you see 1.9 years payback, fully payback. So I think
Yeah, this would be great idea, great initiative, but at this moment currently we are facing this problem. We need to get rid of this with your help.
great, we will just work, we will see how we can come up with some solutions. Biofertilizer out of de-oiled cake. Not yet. There are some small experiments have been done many places. Not a single journal came in which proved that it is really like you do it at the commercial scale, within my knowledge.
It is just because of the gases formed when DOC is there. When you feed the worms with the DOC, because of gases and acidity, the worms are dying. I was told that there is certain new generation bacteria developed which will take up and convert it into biofertilizer. I do not know where the research is going on. Anyhow, it is a great help if for the cashew industry if we can trace that.
So I do know of a few people who have been experimenting, as Shakti said, but there are challenges due to the chemical nature of the de-oiled shell cake. By using the de-oiled shell cake in a turbine process like we described earlier in a power production process, one of the off products is ash, and that ash actually is very useful for fertilizer, depending on the soil conditions in the region that you're based. But the de-oiled shell cake directly as a fertilizer, as far as I know, the challenges in terms of its composition have not yet been overcome.
And cashew nut shell liquid, that liquid, what is the calorific value of that per liter, and what is the exact shell calorific value? Do you have any figures with you?
Yes, on CNSL calorific value is 9,800, and the shell is 5,700, and de-oiled cake is 4,750.
Okay, thank you. And one more last question. What do you call? What is the miscibility of this CNSL with LPFO?
I didn't get your question.
LPFO is used as a fuel for burners in hot air generators and other issues.
Okay.
Yeah, what is the, can we mix it directly with those fuels?
There are a lot of generators which produce steam today in US, Europe, who are using CNSL through injectors as a fuel.
Direct.
Yeah, it's there. It's direct, actually.
Thanks.
Yeah. So thank you very much. I think give a big applaud to the speakers, and thanks for your patience. We just remain here.
Thank you to the moderator and the panelists. We will now move on to presenting the mementos. We will request Mr. Shaktipal to please present the memento. The first up would be Mr. Stefano Massari to receive the memento from Ultramare SARL. Please, round of applause. Next up would be Mr. K.S. Jayaram, Director TMPL. Round of applause once again, ladies and gentlemen. Next up would be Mr. David Barbera, Business Development Director, Naposol AG. And next, Mr. James Obrowski, Program Director, TechnoServe Benin. Once again, a huge round of applause, please, ladies and gentlemen. And also, if I may request Mr. Vasudev Barkur from ETG to come up on stage, please, and present the memento to our moderator, Mr. Shaktipal. Mr. Shaktipal.